says you have to solve the following. So first one, part A, I'm going to do part A, B, and C. Part A is how many edges does a complete graph with 5 vertices have? Explain why this graph is not planar or is planar, and draw the complete graph with 5 vertices and minimize the number of edges that can cross. Alright, so part A, I actually had no idea how to do this, so I looked in the work solutions, and the work solutions that come with your exam gave us this formula. So this formula says to work out how many edges there are in a complete graph, we take the number of vertices we have, times it by the number of vertices, take 1, divide by 2. This formula, according to what I've done some research on, originates to what we call a combinatorial principle. So someone's come up with this, and it's nowhere in our textbook or any of the other textbooks that I've looked at, but it is a principle of graph theory, and from what I got told by Mr. Clifton, it has been put into an exam by the previous teacher. So, using this formula, we're going to work out the number of edges. That means we've got 5 vertices, so it's going to be 5, take 1, divided by 2, part A. This is going to be 5 times 4 divided by 2, which gives us 10. 20 divided 2 is 10. So that's part A. Part B, I'm just going to leave it over here on the side, because to determine whether the graph is planar or not, I need to be able to draw it and see if it is planar or not. So, just to clear up what a complete graph is, it says in our textbook, if there is an edge connecting each vertex to all other vertex in the graph, it is called planar. So, I needed 5 vertices. So, naturally, I went to a pentagon shape. If I call that A, B, C, D, and E, I placed my edges in a pentagon shape. And then need to be able to get all other vertices. So I can go from A to C, and then I can go from A to D as well. So that would be your planar graph. Sorry, that would be your network. And the question, can it be planar for part B? Well, yes. If you can take the the crossing over lines, and we can go from each. Yep. So I'm just gonna. Okay. So I need to connect this line without A to D crossing over. So if I go this way, like that, can't go from A to D without crossing this blue line. So just rub that out. And then see if I can no matter which way I go, I can't connect. I can connect one of them, but then I can't connect the other. So here we'd have to say no. Cannot be a planar graph as lines as the lines slash edges will cross over. And that's the end of that question. Apologies for not going through it in class. I did not know that existed.